Hello friends, welcome to my channel. Today we're going to talk about a very interesting topic called Bias Variance Tradeoff, which is very prevalent topic in machine learning. Let's get right onto it. Alright, so those are the contents. First I'll give you a brief introduction, then we'll see what is bias and what is variance, and then at last what's the trade-off between them. Alright. So first thing, the introduction. So basically, primary goal of any machine learning model is to best estimate the mapping function to predict the output given the input. Okay, so you just want to predict to the best of your model's ability. Okay, there are three kinds of error which we might encounter in the process. First one is the bias error. Second one is the variance error, and the third one is the irreducible error. This kind of error is like dependent on unknown parameters which are out of our control to optimize. What's in our hand are those the first two, bias error and the variance error. So okay, first things, what's a bias error? So bias is basically the difference between the expected prediction of the model and the correct values. It's basically the predicted value, difference between the predicted value and the actual value. That's the bias. Okay, so how far you are from the actual value when you're predicting, that's your bias. So low bias is that your all the predicted points, they are in the specific range, they are near to the actual value. While high bias is that all of your points are in a specific range, but they are quite far from the expected actual range. So the difference between them would definitely be high, which would be the cause of high bias. So here we are actually giving very less attention to the specifics of the data. So our model is oversimplified. As you can see in the graph here, our model is just a simple line that's spanning over this data points. While it should not be like this, it's very simplified model. So that's what one of the thing that says that this your model has got high bias. And the examples would be low bias machine learning algorithms, which include decision trees, KNN, and SVM. Those are the examples with low bias, and the algorithms which are high bias, they include linear regression, linear discriminant analysis, and logistic regression. Okay, this thing is also called as underfitting. You are oversimplifying your algorithm there. Okay, so this can be actually be reduced by doing following things there. If you add more input features, like whenever you are training your model, you first have to take the features and then the target function. You take more features while you are training the model. Okay, and there you add more complexity by including more polynomial features, like if your model's equation is you add x squared, x cube, you add more polynomial features like that. Okay, and then you just decrease your regularization term. Okay, so that's basically what the bias error is. Then we come to variance error. Variance is defined as how the prediction of a given point would change if we took or changed the training data. Okay, so if it's basically like error to small fluctuations in the training data set. If you change something in the training set, then how well your machine learning model performs, that's the variance error. And so basically what happens here is your model, it performs very good on your training data set, but it does not do very well on other sets. If you give the same machine learning model some other test set or validation set, it won't do good. So it's basically it's fitted itself to this particular model or the data points. Okay, so this means that is perfectly fitted to one set. It becomes very flexible, but it fails to perform on other set, which in other words is overfitting. Very hard to get a generalized cost function to predict stuff. You can get a generalized function where you can predict your stuff, so it's very hard. So examples are with the low variance, They are linear regression, linear discriminant analysis, and logistic regression. And high variance machine learning algorithms, they include decision trees, KNN, and SVM. So basically, if you see the thing here, it's basically low bias, low bias machine learning algorithms, they are high variance. And low variance machine learning algorithms, they are high bias. Okay, and how can you reduce that? So in order to reduce your variance, you have to get more training data. Okay, you have to get more of the training data, then you have to reduce the input features. So it's basically in overfitting, what you have done is you have used a lot of input features, which caused your model to be confused, and then it can't go, and it just overfitted everything, and it's trying to do its best, but when you give it too much, then it's not good. And then also you can increase your regularization term. Okay, so what's the trade-off between them? So as I said before in earlier slides, we can say that the low variance models, they tend to be less complex. That is, they are oversimplified. Okay, so for example, linear machine learning algorithms, they have high bias but low variance. And low bias algorithms, they tend to be more complex with flexible underlying structure. That is, the non-linear machine learning algorithms often have low bias but high variance. Okay, it's like they are just inverse of each other, right? So the models which have high bias, they have low variance, and the models which have low variance, they have high bias. I'm sorry, it's the opposite, but yeah, it's vice versa. So for example, what you can do here is it actually depends on your requirements. You know what you want. If you want high variance or high bias, then this is actually, there's no escaping this fact that there is a trade-off between them, and depends on how you use your algorithms and which one of the both which you like to reduce, right? For example, the KNN algorithm has low bias and high variance, but the trade-off, it can be changed by increasing the number of value of k, which increases the number of neighbors, and which in turn increase the bias of the model but reduces the variance. Okay, and then in SVM also, SVM has low bias and high variance, but it can be changed by increasing the C parameter, which influences the number of violations of the margin that is allowed in the training data, which increases the bias but it decreases the variance. So yeah, that is what the trade-off is between them. Thank you for watching, and if you have any comments, please comment below. Thanks.